Thank you, Preet. Thank you for the awesome introduction. Huge kudos to you and the organizers for putting together such a great conference. As for audience members, good morning, afternoon, night, or anywhere in between. I'm super excited to be here and talk about my topic, which is visualizing design tokens at scale. It's a subject matter I love. It's an intersection of my personal career and educational interests. It drives my curiosity a lot. And I'm just super happy to be here and on this virtual stage from Astoria, Queens, and be a nerd about design systems and share that passion. A little bit about myself before diving into the talk. My name is Nahiyan Khan. My pronouns are he, him. I currently work at Lifion by ADP, which is a innovation unit owned by the payroll company ADP. We make HCM software. So our design system drives a suite of applications that are all human resource in nature. On the side, I'm doing a part-time master's as well in engineering from Johns Hopkins University. Some of my concentrations are enterprise web development, data visualization, hint, hint, and also DevOps. I figured the rest of my introduction, just to kind of show myself better, is better told through pictures than bullet points. So, a bit more about myself. To walk through the pictures a little bit, that's my wonderful partner, Natasha. She happens to also work on a design system at her company on the side. However, that is not what brought us together. Um, that's my cat, who I like to joke knows a lot about design systems just because she's here, staring at me judgingly and listening to everything. Fun fact, I have license plates that say I am a car in two different states, and it always gives me a chuckle. On the lower, that is a picture of our design system team at work. We were all celebrating launching an internal design system website with amazing donuts. Personal interest wise, I love rock climbing. If you're in New York, you want to climb together, hit me up. Let's do it. So, this talk. This talk, the foundation of this talk is mostly comes from an independent project that I did as part of my class, the data visualization class. Career wise, I've always worked on design systems. I mentioned it's a passion. I started intersecting it with what I was learning in school, and I realized that it was helping me reframe problems, but also interpret design from different points of view. So, this talk will be centered on our design system. I will walk through some of the challenges we face, how we have tried answering those challenges using design tokens. Then, the core part of this talk, which is visualizing all of it, the tokens. And then, next steps on where I want to take it next. So let's dive right into it. The design system. Our design system is comprised of a range of skill sets. So we work on component designs, we work on patterns, content guidelines, vision projects, and also community building, both with designers and with engineers. We are always in a constant process of iteration. We're making discoveries, we're learning, we're receiving feedback, which can be both positive and negative, and both are good feedbacks. So, with all that in mind, we try to ensure on an ongoing basis that we're providing the best experience, the most consistent experience we can to our end customers. Some of the challenges that I mentioned, to kind of walk through them, um, it is challenging because a lot of our choices have global system-wide implications. And in an enterprise setting, that happens at a massive scale, which is across multiple different technology stacks. It's across multiple different devices and different user settings as well. One of the challenge questions that I posed over here is, how do we keep track of a design choice in such a scale? So if we build a concept, a visual concept, let's say a certain type of an interaction hover, which shows up in multiple components. How do we keep track of it and know when and where it shows up? So if we ever were to evolve, how does it happen? Which leads to the next question: how do we iterate and evolve safely? So, taking the case of the last example, if our brand changes, if our visuals changes, how do we ensure that we can do it efficiently but also safely when we make a change that impacts multiple different areas? The last question I'll pose is, how do we convey that said change in an efficient manner? So, from a design system point of view, I mentioned we have global implications. So, when we make a change, we also kind of need to have insight and data that backs up where did that change happen? How do we communicate it to designers? How do we communicate it to product owners? And also, how do we communicate it to engineers? So, with all that in mind, the basis of our design system does use design tokens, and that is the mechanism we keep in mind when we try to answer these questions. So, design tokens. Design tokens, if you are not aware of them, I'll go through a little bit of a brief. And if you are, here's sort of my interpretation of how I see them. They're awesome. In my opinion, I think of them as a mechanism to store design choices. So a very specific text color that shows up in a very specific button that shows up which is using a very specific color from our palette. Those individual decision points are all choices, and design tokens allow us to capture them. Furthermore, design tokens are also abstractions that provide meaning and flexibility. So when I mention a very specific color choice, let's say we have a color in our palette that's called red 500. Red 500 inherently doesn't indicate how should I use it. But if we were to abstract it as a text color danger, now I know that it's a form of a text color and it's conveying the sense of danger. It has a purpose and it provides us flexibility whenever we want to change that purpose. The last way that I interpret tokens are as a communication device. You may have heard of the phrase developer handoff, which happens between designers and engineering. However, I interpret it more as a handshake. It's a communication. And design tokens allow this communication to happen all the way from ideation to implementation. The same language is spoken, the same concepts are spoken, and we have a handshake on understanding on it. So, implementation is one of the strongest plus points of why a design system might end up using design tokens. The design implementation. So I talked through some of those examples of a text color. We might have a token that captures, let's say, our typography choice for a header Excel. It captures the font size. It is around this part of when we were setting up our tokens that I started realizing, thanks to my class, that, hey, we are essentially saving design choices as data. And data is powerful. If we can parse it, we can interpret it, we can navigate it, it becomes a very, very strong tool. So I started interpreting design tokens not just as a mechanism for communication, not just as a mechanism for implementation. If we were to flip this concept, it's also a mechanism for design data. So a text color danger, we can parse and figure out how many times was it used. A typography header, extra large size, we can parse and figure out where was it used. Was it used in a modal? Was it used in a card? And those are all crucial information that from a design system point of view, we want to keep track of because it's the markup of our system, and so on. So these are the ideas that were playing in my head as we were working on this. So I was very motivated to sort of influence our infrastructure, our token infrastructure, in a similar way so that we also had access to crucial information and we could utilize it. So to walk through what that means from an implementation or a data point of view, let's walk through a little bit of like how our infrastructure is set up. I set up our structure in terms of layers, and each of those layers provide us with a certain type of data point and a certain type of information. The first layer is all the specs of our system. These are just system specs. They don't inherently mean anything, but these are all the little pieces that we put together to build our UI. Red 500, the earlier example. The second layer goes through a transformation or an abstraction of Red 500 and turns it into a concept, a tangible concept that has a meaning that we can now use. So Red 500 becomes text color danger. I know in what context I should use this. I took this structure a level further onto a layer 3, which is now component specific. The text color danger shows up in a button. That button is now a button danger color. I will make one point over here, which is this talk won't go into sort of how our tokens are named. The examples that I'm showing are also simplified to an extent to kind of illustrate a concept. So the final token, the endpoint, is capturing where did text color danger get used in a component. Now, you can imagine that in a system which has multiple components and multiple choices and everything, this is a process that repeats itself over and over again. So we could have another version of this, which happens to be, let's say, blue 500, that happens to be our text color primary. And that ends up getting used in a button, in a primary button's color. This repeats itself, as I mentioned. It could also be the case that, hey, that same red 500 that we had also happens to be our border color for danger. And it's being used in our notification component. So you can start seeing a little bit of like how the same value, which is red 500, gets abstracted to different concepts and it gets used in different ways. I mentioned earlier, in scale, now when you have 30 plus components, some of them very complex, some of them simple, you repeat this process, you multiply, and yeah, you start getting a web of information that is capturing design values all the way to choices and all the way to implementation. So it gets a little overwhelming, and that's exactly what it is. It is very overwhelming. So when we started like seeing a version of this like being built up, we were realizing that, oh gosh, this is a little hard to keep track of in our mental model, this web. To further illustrate that point, here's a little bit of a statistics on what the end result kind of looked like. The numbers are rounded a little bit. I'm also looking at them and realizing that I did my math wrong. So let's ignore that little piece. This is just for our web implementation alone. We have a total of around 2,100 tokens, of which about 350 of them are these system level values, hex values, font sizes that don't inherently say anything about where it should be used, line heights, icons. Those are then converted to the concepts, which is our second layer. And there's about 250, 275 of these concepts. The biggest layer of all is layer 3 because it is keeping track of every decision point. So the contextual layer, the contextual tokens, kind of rack in about 1,500. And as I mentioned, this is just for the website, the web implementation. And I'll keep the focus of this talk on the web implementation. Mobile adds a lot more of these values. So as mentioned, that is a lot of information. And we realized that as we were iterating on our designs and everything, we were having conversations and decision scenarios where it was a little hard to mentally track sort of like, hey, if we are making our text color darker in this one instance, is it going to affect other components? Do we want it to affect other components? It's hard to find that data. It's possible. It's hard and time consuming in the sense that our designers working on the kit might have to go through their kit, visually look at them, and sort of get an understanding. Our engineers who are working in code might have to look at multiple files, do searches to kind of get that information. And a lot of this is what ultimately led me to pose we need a better way to visualize it, to see what this looks like, to navigate it, to search it, so that we have a tool that lets us interpret the markup of our system. Which brings us to visualizing this. So before getting to the show and tell part, I'll talk through a little bit of like all these things. How did I take them and convert them to create a visualization? So this is a little bit of the tech savvy part of the talk, what happens under the hood. I'll still keep it a little bit simplified. Our tokens are saved in a node module format. Typically, tokens are saved in JSON. I chose node modules because it allowed me more flexibility to pre-process the tokens before they're even outputted, to run automation, to run scripts. As an example, one of the scripts that we run is when I make a choice for a text color, and if it has an equivalent background color, right then and there, we run a script that validates whether that's an accessible choice. And that happens even before that token is outputted for implementation. That is what I saw as a power of using node modules instead. We are using Style Dictionary, which is one of the most popular token processing tools. It's awesome. It has worked really, really well for us. Style Dictionary is what then eventually outputs the tokens for our different implementations. On top of that, I had to run some custom data pre-processing. So when we output the tokens for implementation, it is not in a format that I can sort of take and build into an analytical tool. I had to pre-process them. To give a little bit of a detail on that, the pre-processing involved actually creating two data sets. One, which is just keeping track of the token itself. What is its name? What is its value? And other details around it. Its color contrast. The other data set is keeping track of connections. Which token is connected to which tokens? Those are what we ended up calling links between tokens. We then get the data that we can start parsing. So I relied on D3 for this. D3 has a type of a chart that's called a Sankey diagram. There is a layout engine that D3 provides where you can put these data and it tries to sort of map it onto a page in terms of how it's laid out. Unfortunately, it's not a very optimum layout engine, and it's something you will see in the demo as well. The other part of this is normally D3 generates everything using SVGs. When I did that, it was very, very badly performant. SVGs could not handle the amount of information that was on the page at one point. So instead of SVGs, I converted the data that was being outputted by the layout engine into React. So our front end for the visualization is built in React using Gatsby.js, which is an awesome, awesome framework. Finally, we have the visualization. But in order to fully grasp its power and navigate it, I also had to build a custom search algorithm on top of it. Custom because of the nature of the data. It's a network data. When we search for something, the search has to keep track of, if I find a hit, what else is it connected to? And when it's connected to something else, what else is that connected to? So the whole network. So all these is what ultimately leads us to where we are, which is we now have the capability to visualize the design tokens at scale. This is the show and tell part of this talk. So to dive right into it, I'm going to transition to the visualization. At this point, I hope you can start making the connections on why I called it a web and also why I called the layout algorithm not quite as optimum. Let's go through a few of the feature sets and sort of what this looks like. So we can zoom in and out. So I'm going to start by zooming out. Yes, that is a massive amount of information. Oh, I scrolled off. And if I go all the way down, this in one view is capturing every visual design choice of our system. No stones left unturned. All of the choices are captured here. I can also zoom in if I want to read a certain thing. So if I scroll all the way up here, earlier I mentioned sort of like each color, there are contrast ratios that are captured as well. So here's an example of a token color with a certain contrast ratio. So I mentioned the search. I would say that search is my second favorite feature. So to illustrate that, if I wanted to look at all our text colors, I can search for it. And this is the network of our text colors. We can search for backgrounds. We can search for components. We can also search of more or not quite tangible concepts, like let's say an interaction or a hover disabled. And we get the tally on the spot. As I did a few of these searches, you might have noticed that there are things that are overlapping, due to the layout engine not being quite as optimum. So I'm just going to refresh this page, which then kind of resets it. To talk about what my favorite feature is, and the one that I think provides the power, is I can click on a token and actually end up seeing what is its pathway. So I use the simplified example of red 500 being our text color. Turns out it's red 700. So we have a red 700 system spec token, which is converted. I'll skip the middle part to our text color negative. Negative is the name that we finally ended up choosing rather than danger. As mentioned, won't really get into sort of like the naming schema and decision making over there. But then the power, which is this negative text color, it shows up in a few places. I can see it shows up in one of our button styles, in a component called a file uploader. It shows up in our input validation. It also shows up in this timer component that we have. And I can do this and figure out what is our mapping for everything. Earlier, I gave an example of certain color choices might be abstracted to multiple things. So in this case, here is a case where a certain color choice is actually abstracted to 3 different concepts. It happens to be the same color, but it's used in different contexts. As a background color, as a border color focus, as a interaction color as well. So, and we can see that. Now, I was intentionally using subsets of this data. This also does work when the full mapping is out here. And in my opinion, it gets kind of wild, but also fun. It gets very fun to navigate. So this one looks like it's connected to a lot of things. Oh yeah, and it also gets a little slow. Not optimum, which is why it's all going up there versus being very close together. If I keep scrolling all the way down here, let's see, does that? Not as much, not as much. I do remember there were certain ones that I think just visually looked very nice. That looks nice. But it's also conveying a lot of crucial information. So, earlier I mentioned sort of there are questions that we face in a system when we have to make choices. Let's kind of call back to them a little bit to kind of see how such a visualization can actually help us with those challenges that we normally end up having. The first question that I posed was, how can we keep track of a design choice? If we go back to the visualization, Taking the example of, let's say, an interaction hover. If we are making a new component, let's say, and it has interactive elements in it, it's easy for us to kind of come here and then look at where else it shows up so that we can kind of keep it in sync, or we kind of get an understanding logically, is it the same thing or not? So we are able to see that quite quickly and efficiently. To pose the second question, how do we iterate and evolve safely? Now, I showed examples of a system in its current state of being. However, it evolves. The system evolves. I'm going to show an example back to the red where I mentioned that we adopted the term negative. Now, it used to be called danger. And when we were iterating on what do we want to call it, conceptually, is it capturing everything we wanted to capture? We used this tool to kind of look at where all our danger scenarios were. But also, we realized that we were seeing scenarios where we're choosing a red color, but it's not an error. It's not destructive in nature. It's sort of just bad or has a negative connotation. In data viz, it shows up. In statuses, it shows up. So we use this tool to then kind of start mapping and reorienting our connections to see what had to change in order to make sure that our endpoints stayed the same. To kind of walk through a little bit, we have a negative base that connects to those things. If we were to rename this or to actually split it up, we would still have to ensure that those connections were met. And this allowed us to see that very quickly. The last question that I posed earlier was, how can we convey change efficiently? So when we do make an intentional choice to update it, a certain level of communication needs to happen. For designers, or let's say internal design system designers that are working on our kits, going back to the viz again to kind of talk through it. Let me see if I can use a different example. Let's go to background color. Ooh, we have a green over here. A positive background color, which is only used in one place, so that is not a good choice. Let's go with this. So we have a concept of a subtle background color that is interaction in nature. Now, hypothetical scenario, the contrast ratio is off. We need to update this. If we update it, we can immediately tell our designers that, hey, these are the instances that it used to show up in. All of those needs to be updated as well. So in our kit designers, we use Sketch at our company, now knows that, hey, I should make sure that all of these updated as well. That's on the designer end of it. On the engineering side, we are working with our product owners, we're working with the engineering tech leads, and if we make this choice, we can tell them, hey, this is to a extreme precision where the change is going to show up, which in our case, we have been able to then convert into what are the test scenarios we have to run. So I can give a list of like, these are the very specific places it's showing up in, run those test scenarios. So this data is now hooked up to what test scenario is represented by these choices, and only run the test that the data is telling you to run, which has been an efficiency and immense cost savings. So that is sort of how we were aiding our choices in this discovery, and also teaching the people like, here's what's really happening when we make a choice like this. So to go back to the presentation again, I want to conclude this by saying that the viz is not everything, but it is supercharging a lot of our decision points and how we are making it, because it gives us this analytical sense of like looking at what's happening, where is it, and everything. And that is very, very crucial time savings. Where do I want to take it next? So, all right, next steps. I want to keep iterating on it. Um, the state that the Viz is in right now, I think a lot more things could make it much, much more powerful. I mentioned that the layout is not as optimum. I want to make it more optimum. There hasn't been anything open source that I found. So this is one of those curiosity places for me. Can I make it more optimum? Going back to the Viz to illustrate the next point, hey, this is very, very nice to see what is being impacted and what values. But I think it would be super, super cool if right next to the endpoints, I could see the component it's affecting. So if I were to search for a hover, I want to see all the components that has hover, and I can play with it right here. So think of it as a merging of this with a storybook-like environment where not only are we searching by component, but we could be searching by color and seeing on the spot every component that is inheriting that color. I think that is a next level step for this. The next point I want to make is groupings. So this kind of touches on the layering bit a little bit. Things are not grouped, and this is something that I'm stuck with how D3 renders all of this. Um, in terms of groupings, maybe I want to see all my typography groupings in one place. Maybe I want to see all the component being grouped together. And I think it would help quite a bit with how sort of like all of them either show up together. Because as of right now, even for the same component, let's say, things are kind of split apart with too much distance in between. Because the visualization is so big, I think having a mini map is going to be super fun. It is something that I've experimented with, but have not quite finished wrapping up. So a mini map like in the corner, sort of like how you might see in video games, and you can click on it and kind of like navigate to this. The last part goes into a little bit of the tech side of things again, where the way that the data is captured and surfaced across the board, I kind of want to make it into a GraphQL layer so that this sort of an information is always there. It's not tied to just this visualization. It could be opened up to do more enhanced fizzes or processes or automation when all of this information is sort of like readily available for people to tap into as an AI API. With that said, a next step that I attach myself with a lot is actually giving back to the community. So everything that I've shared up to this point, I am making a commitment that I want to open source it, and I will open source it. Uh, I have sort of like come to this point with so much of the knowledge that's shared by key design system advocates and other companies, and it is a culmination of all that knowledge that sort of allowed me to think through how it all comes together and what more can we do with it. So it's fair to give it back as well. So we should stay connected. Please connect with me. I posted my LinkedIn, my Twitter, my GitHub here. I will also share out the link separately, even though capturing it here may not be as seamless. I am not very active on Twitter, but hey, now I have a reason to be. And GitHub is, of course, where a lot of this will eventually show up. It is not currently live, it is in active development. I'm actively sort of like abstracting it and making sure that it is in a way that could hook up to different style dictionary instances that you might use, and also documentation on the type of data processing needed to then hook up to this. It's something I'm actively working on. If anyone is interested in partnering on it, please hit me up. I would love to do a lot with this. With that said, thank you very much for sticking around, listening, and giving me the opportunity to share all this passion and my curiosities with everyone here. Thank you with the important tag in CSS. Sorry, had to. I guess actually, if you have noticed, all the slides were tokens. And in this case, this is important. I appreciate this. Thank you. We will now go into the Q&A portion of it. So any questions that you have, anything that I may have captured or not have captured, or any tangent, please, I'm here to answer.